10 days. 10 days of surviving the Van Allen radiation belts on the way out. 10 days of cosmic rays passing through the capsule hull and through human tissue and through DNA that the body's repair mechanisms worked continuously to fix. 10 days of microgravity slowly pulling calcium from bones and fluid from the cardiovascular system and muscle mass from limbs that had nothing to push against. 10 days of a sealed environment 16.5 feet wide, containing 4 human beings and every system required to keep them alive at 450,000 kilometers from the nearest breathable atmosphere that existed outside a machine. 10 days survived. And now, at the end of all of it, after everything the translunar environment threw at the crew of Artemis II and everything the engineering kept between them and it, 4 human beings are sitting inside a capsule falling toward Earth at 39,000 kilometers per hour, and they have 4 minutes to survive the air. Not the vacuum, not the radiation, not the cold of deep space or the heat of direct solar exposure or the mechanical violence of launch. The air, the same substance that every human being who has ever lived has breathed from their first moment outside the womb, the medium through which sound travels and birds fly and weather moves, is about to become the most dangerous thing the Artemis II crew has encountered in 10 days of exposure to the most hostile environment our species has ever deliberately entered. At the velocity of translunar return, air is not a gas. It is a wall. It is a compression event. It is a physical force that at 39,000 kilometers per hour cannot move out of the way fast enough and instead stacks up in front of the capsule in a shock wave that converts the kinetic energy of the falling spacecraft into heat with an efficiency that produces temperatures outside the heat shield that exceed 5,000 degrees Fahrenheit. Half the surface temperature of the sun, generated not by combustion, not by any internal energy source, but purely by the physics of a solid object moving through a compressible medium at a velocity that the medium was never designed to accommodate. The crew has survived everything the universe threw at them for 10 days. They now have 4 minutes to survive the consequences of coming home. The skip entry maneuver that Orion performs during its return from translunar trajectory is not a standard atmospheric entry. Every crewed spacecraft that returned from deep space before Orion, specifically the Apollo command modules, executed a direct ballistic entry. They hit the atmosphere once at a precise angle and rode the resulting deceleration arc to splashdown. The direct entry approach works, it is proven. It is also demanding on the heat shield because the entire deceleration from entry velocity to parachute deployment velocity must occur in a single continuous heating event, and it produces peak deceleration forces on the crew that are significant and not trivially manageable for human physiology. Orion's skip entry is a different approach to the same problem. The capsule contacts the upper atmosphere at a shallow angle, decelerates partially, generates lift from its capsule geometry during the deceleration, and uses that lift to climb back out of the dense atmosphere before the velocity has dropped to parachute deployable levels. The capsule then follows a second descending arc that brings it back into the atmosphere for the final deceleration and parachute deployment sequence. 2 contacts with the atmosphere instead of 1, 2 heating events instead of 1, 2 deceleration pulses instead of 1. The engineering rationale is sound. The skip approach reduces peak heating rate, reduces peak deceleration forces, and increases the precision of the landing zone by allowing the trajectory to be shaped during the skip phase in ways that a direct entry cannot accommodate. It is objectively a superior approach to the physics of the return problem for a vehicle with Orion's mass and geometry. It is also an approach that has been executed successfully exactly once in a crewed mission context, which is 0 times because Artemis I flew without crew. The first time human beings will experience the skip entry of an Orion capsule returning from translunar space is Artemis II. the first time the system is tested with the specific loading conditions that 4 human bodies inside the capsule create, with the specific center of mass distribution that 4 suited crew members produce, with the specific capsule mass properties after 10 days of consumables usage, is the mission. The math has been validated, the simulations have been run, the Artemis I data has been analyzed, and the physics does not care about any of that. The physics only cares about the angle, the temperature, and the time. 4 minutes. That is the entire bet. And we have placed it.
Apollo was a sprint. 12 days for the longest mission, 8 for the shortest. Get there, plant a flag, collect rocks, come home before anything catastrophic had time to accumulate. The engineers who designed the Apollo hardware understood that they were building for a sprint, and they optimized accordingly, accepting risk profiles that a longer mission duration would have made unacceptable, pushing hardware and human physiology to margins that worked precisely because
Artemis
the exposure
II
window
is about
was
to
short
send
enough
humans
that the
into
margins
situations
held.
no one
Artemis
has ever
II
experienced
is not
before.
A sprint. It is a 10-day
For more than 50
endurance
years,
test
no astronaut
conducted
traveled
inside
beyond
a
low Earth
pressurized
orbit.
aluminum capsule
Since
16.5
1972,
feet wide,
every crewed
orbiting the
mission
moon
stayed
at
inside
velocities
Earth's
that make
protective
emergency
magnetic
return
field.
impossible.
Generations
In a
grew up
radiation
with space
environment that the
stations,
sun
shuttle
is
launches, and
currently
robotic
making
probes,
significantly
but
more
no
hostile
human
than
went
it was
back into
during
deep
any
space.
Apollo mission, with
Now that
4 human
changes.
beings whose bodies
Artemis
were
II is not a
evolved over
continuation
millions
of
of
Apollo.
years for an environment
It is not
that
a sequel
stops
mission
existing
repeating
the moment
history.
the hatch closes.
It represents
and the
a
launch
different
sequence
technological
initiates.
era,
The
a
public
different
narrative
philosophy of
surrounding
exploration,
Artemis II
and a
is
completely
narrative
new
of
approach
triumph,
to
of
surviving
return,
beyond
of
Earth.
humanity reclaiming
Let's start
its
with something
place in
simple.
the cosmos.
Space
This script is
inside
not
the
that
spacecraft.
narrative. This is the
The
other
Apollo
document,
command
the one that
module gave 3
describes what the
astronauts
4
about
people
210
inside that
cubic
capsule
feet of
are
habitable
actually going
volume.
to experience
That
in
is
their
roughly the
bodies,
size
in
of a
their
large
cells,
closet.
in the biological
3
reality
people lived
of
in
what
that
it means
confined
to be
space
a
for up
living
to 2
organism
weeks.
in an environment
Orion,
specifically
the spacecraft
structured to
flying
kill
Artemis
living
II,
organisms.
provides
This
about
is the human
330
toll.
cubic
The
feet
first
for
thing
4
that happens
astronauts.
to the human body
That is
during
nearly
the Artemis
60%
II launch
more
sequence
room.
is not dramatic
It is still
in the way that the
compact and still
external
demanding,
spectacle is
but
dramatic. From outside the spacecraft, the ignition of the Space Launch System's 4 RS-25 engines and the simultaneous ignition of the twin solid rocket boosters is a visual and acoustic event of extraordinary scale. 5.5 million pounds of thrust, converting liquid hydrogen and liquid oxygen and solid propellant into controlled violence at a rate that produces 15% more thrust than the Saturn V. From inside the Orion crew module, the experience is different. The vibration begins before the vehicle clears the tower, not the clean mechanical vibration of a precisely balanced system, but the broadband acoustic vibration of a structure being shaken by combustion at frequencies that span the entire range of human auditory perception and extend well below it into the infrasound range that the body feels rather than hears. The crew's vision blurs, not from acceleration forces yet, but from the vibration frequency coupling with the resonant frequency of the human eyeball, a phenomenon called visual disturbance that mission planners account for and that training prepares the crew for, but that preparation does not eliminate. The crew cannot read their instruments clearly during the peak vibration phase of ascent. They are monitoring by memory and by feel, while the vehicle shakes at frequencies that make precision visual tasks impossible. Then the acceleration builds. The solid rocket boosters are providing more than 75% of the initial thrust, and they are not throttleable. They burn at their design thrust level until they are exhausted, which takes approximately 2 minutes, and during those 2 minutes, the crew experiences a sustained acceleration load that peaks at approximately 3.5 g. 3.5 g means that every kilogram of body mass is experiencing 3.5 kilograms of effective gravitational force pressing it into the seat. A person weighing 80 kilograms effectively weighs 280 kilograms during peak acceleration. The cardiovascular system
Also more powerful than the one that carried Apollo crews.
And blood pressure to
While Saturn
maintain
V
adequate
defined an era,
perfusion to
the
brain
Space Launch
against
System
the
produces
increased
even greater
effective
thrust at
gravity
liftoff.
draining blood toward
Both
the lower
rockets
body.
are
The
expendable
respiratory
heavy
muscles
lift
work
systems,
harder
but
against the
Orion sitting
increased
on
weight
top
of the chest
represents a
wall.
generational
The spine
shift.
compresses under
Apollo
the increased
spacecraft
axial
generated
low.
electricity
None of this
using
is
fuel
acutely
cells.
dangerous for a healthy,
Once
trained
reactants were
astronaut
consumed,
in a properly
power
fitted
margins
launch
narrowed.
suit in the correct body
Orion
position.
unfolds
All of
large
it is a
solar arrays
significant
once in
physiological
space,
stress
generating
event that the
continuous
body
electrical
registers
power
and
as long as
responds to
sunlight
at
is
the
available.
cellular level.
But
Initiating
regenerative
stress
capability
response
allows for
cascades
stronger
that will take hours
redundancy
to
and greater
resolve
flexibility
after
in
the acceleration
spacecraft
phase
operations.
ends. The crew
Another
of
difference
Artemis
is
II
international
will spend the
collaboration.
first several hours of their mission
Apollo
with
was
their
a
bodies
national
recovering
effort.
from the physiological
Artemis is
shock
global.
of getting off the ground.
The Orion
when the
service
solid
module
rocket
was built in
boosters
Europe.
separate 40
A
kilometers
Canadian
above
astronaut
the
is
Earth,
part of
and
the
vehicle
Artemis II
continues
crew.
on RS-25
Future lunar
engine
missions
thrust
will
alone.
include
The
hardware
acceleration
contributions from
profile
multiple
changes.
international
The remaining
partners.
thrust is lower,
Deep
smoother,
space exploration
more controlled,
is no
but the
longer a single
environment
nation's
outside
project.
the spacecraft is changing
Inside
in a way
Orion,
that the
the
instruments are
computational
registering
difference is
and the
dramatic.
crew understands but
Apollo's
cannot
guidance
feel
computer
directly.
operated
They are
with about
climbing through
72
the atmosphere,
kilobytes of memory.
the atmospheric shielding
Today,
that has protected
even
the
simple
crew from
devices
space
exceed that
radiation
capacity
since
by
birth.
millions
The
of
column
times.
of air above their heads
Orion's
that
flight
absorbs
computers
the
are
majority
tens of
of the
thousands of
cosmic ray
times more
flux and
capable
the
than
solar
Apollo
particle
systems.
radiation
The
before it
cockpit
reaches
is fully
the surface
digital,
is thinning
using
at
advanced
100
displays and
kilometers. The
software-driven
Kármán line, the
interfaces
conventional
rather than
boundary of
rows of
space,
analog
the atmospheric
switches.
shielding is
Apollo
effectively
astronauts
zero.
depended
The crew
heavily
is
on
now
mission control
exposed
for
to the full
calculations and
flux of the
trajectory
space
updates.
radiation environment.
Orion is
They have
designed to
crossed from the
function with far
biosphere
greater
into
autonomy.
a region where the physical
Artemis
forces
II
that shaped
astronauts are
biological
actively
evolution
testing
for
manual
4
piloting
billion
modes in
years
deep
do not
space,
apply.
preparing
The
for a
suits
future where
provide some
communication
protection.
delays
The
make
spacecraft
real-time
structure
assistance from
provides
Earth
some
impractical.
protection. Neither provides
Communication
the
itself
protection
has
that a
changed.
kilometer of atmosphere
Apollo
provided
relied
from the
entirely
moment they
on
were
radio
born
transmission.
until the moment they crossed the
Bandwidth was
Kármán
limited.
line. The radiation
Images took
exposure
significant
begins
time to send.
accumulating from that moment,
Orion
and the
carries
environment
laser
into
communication
which they are
technology
flying
capable
is
of
currently
transmitting
more
high volumes of
radioactive
data
than any
at far
environment
greater
that any
speeds.
Apollo crew
High-resolution
encountered.
imagery
The sun
from deep
operates
space
on
can
an
be delivered
approximately
far more
11-year
efficiently than ever
cycle of
before.
magnetic activity.
The view
At
of the
solar
moon will
maximum,
also be
the
different.
frequency and intensity
Apollo
of
crews
solar
flew relatively
energetic
low
particle
over the
events,
lunar
coronal
surface,
mass
seeing
ejections,
terrain in
solar
close
proton
detail.
events, the various
Artemis
categories
II
of
follows
solar
a trajectory
activity
that
produce
allows
significant
astronauts to view the
increases
entire
in the
lunar
particle
disk.
radiation environment of the inner solar system reach their peak for the cycle. The Apollo missions flew during a period of solar activity that included one significant solar proton event in August 1972 that occurred between Apollo 16 and Apollo 17. The timing was fortunate in a way that the astronauts themselves have acknowledged. Had that event occurred while a crew was in transit, the radiation dose received in the unshielded translunar environment would have been severe and potentially fatal. The Artemis II mission is flying during a solar maximum period. The statistical probability that a significant solar energetic particle event will occur within the 10-day mission window is meaningfully higher than it was during any individual Apollo mission. Mission planning accounts for this through space weather monitoring and through the storm shelter provisions within the Orion crew module. The accounting does not eliminate the risk. It manages it to an acceptable level, and acceptable in the context of human spaceflight risk analysis means something different from acceptable in most other engineering domains. What happens to a human cell when a cosmic ray passes through it is not a metaphor. It is a physical event with physical consequences that the cell's repair mechanisms may or may not be adequate to address. A high-energy proton from a galactic cosmic ray or a solar energetic particle event travels through the spacecraft hull and through the human body at a significant fraction of the speed of light. As it passes through biological tissue, it ionizes the molecules in its path, stripping electrons from atoms and producing reactive chemical species that damage the molecular
response
structures
and radiation
at contact.
dosage in
When
far
the
more
path of the
detail than
particle
during Apollo.
passes through a DNA
The
molecule,
data collected will
the
shape
ionization
mission planning
events
for
can
future
break the
journeys,
chemical
including
bonds
Mars.
holding the DNA
For the
strand
first time in
together,
history,
producing
4
strand
humans
breaks
are traveling
that the
in
cell's
deep
repair
space
mechanisms
simultaneously.
must identify and
Apollo
correct.
missions
Single
carried
strand
3 beyond
breaks
Earth
are corrected
orbit.
efficiently
Artemis
in most
II
cases.
expands
Double
that number,
strand breaks,
marking
where
the
both
largest human
strands of the
presence
DNA
ever
double
this far
helix
from
are
home.
broken in close
And then there is the
proximity,
silence.
are more challenging for
When
the repair
Orion passes
machinery
behind the
and more
moon,
likely to
communication
result
with
in
Earth
either
will
cell
stop.
death or, in
No
the worst
signal
case
can
scenario,
penetrate the lunar
mutations
mass.
that alter
For a
the
period of
cell's
time, the
behavior
crew
in
will be
ways that may
completely
not
cut
become
off.
clinically apparent
Apollo
for years
astronauts
or
experienced
decades.
that
The
same
crew of
silence
Artemis
decades
II
ago.
will spend the first
That part
several
has not
hours of their
changed.
mission with their
The
bodies
moon still
recovering
blocks
from the
radio
physiological
waves.
shock of
Space
getting off
is
the
still
ground.
vast and
When the
quiet.
solid rocket boosters
But everything
separate
surrounding
40
that
kilometers
silence
above
is new.
the Earth and the vehicle
Apollo
continues
proved
on
that humans could reach
RS-25
the moon.
engine thrust alone,
Artemis
the
is testing the
acceleration
systems
profile
that will allow
changes.
humans
The
to
remaining
build a
thrust is
sustained
lower,
presence beyond
smoother,
Earth.
more controlled,
Life
but the
support,
environment
navigation,
outside the
communication,
spacecraft
radiation
is changing
monitoring,
in a way that the
re-entry
instruments
systems,
are
all of it is
registering
being
and the crew
validated not just for a
understands, but cannot
flyby,
feel
but
directly.
for
They are
long-duration
climbing
missions
through
in the
atmosphere.
future.
The atmospheric
This mission is not about
shielding that has
repeating
protected
history.
the crew from space
It is about
radiation
extending
since
it.
birth. The
Right
column
now,
of air
4
above their heads
astronauts are
that
farther
absorbs
from
the
Earth than
majority
anyone
of the
has been in
cosmic
more than
ray
half a
flux and
century.
the solar particle
They are
radiation
flying in a
before it
spacecraft
reaches
more
the
advanced
surface
than
is
anything
thinning
Apollo
at
engineers
100
could have
kilometers,
imagined.
the Kármán line,
Yet at
the
its core,
conventional
the
boundary
challenge
of
remains
space.
the same.
Atmospheric shielding
sealed
is effectively
capsule.
zero. The
Air
crew
to
is
breathe,
now exposed
water
to the
to
full
drink,
flux of the space
protection from heat,
radiation environment.
radiation, and
They have
vacuum,
crossed from the
and a
biosphere
safe return
into a
home.
region where the physical
The silence
forces
behind
that
the moon
shaped
remains
biological
unchanged.
evolution for 4
Everything
billion
else has
years
moved forward.
do not apply. The
Have you ever
suits
wondered what it
provide
would be
some
like to
protection.
explore
The
deep
spacecraft
space?
structure provides some
For over
protection.
50 years,
Neither
humans have
provides the
stayed within
protection
low
that a
Earth orbit.
kilometer of atmosphere
The last
provided
crewed
from
mission
the moment
beyond
they
that
were
was in
born until the moment
1972.
they
The seal takes 4 seconds to breach completely. In the first second, the pressure differential between the suit interior and the lunar vacuum outside begins forcing gas through the compromised seam at a rate the suit's emergency systems cannot compensate for. In the second second, the atmospheric pressure inside the suit drops below the Armstrong limit, the threshold at which the ambient pressure is so low that liquid water at human body temperature spontaneously transitions to vapor. In the third second, that transition begins occurring not in a glass of water, not in a laboratory apparatus, but in the moisture lining your lungs, in the fluid surrounding your joints, in the saliva in your mouth, in the blood moving through the capillaries closest to your skin surface. In the fourth second, you are still conscious. You can still feel everything. The Hollywood version of vacuum exposure, the dramatic, explosive decompression that ruptures the body from outside in, is wrong in almost every specific detail. You do not explode. You do not freeze instantly. You do not lose consciousness in the first moment. What happens is quieter and more methodical and considerably more thorough. The vacuum does not attack you. It simply removes the pressure that was keeping your body's chemistry in its operational state, and your body begins, with complete physical indifference, to come apart from the inside. The Armstrong limit sits at approximately 6.3 kilopascals of atmospheric pressure. At sea level on Earth, the pressure is 101.3 kilopascals, enough to keep water liquid at temperatures up to 100 degrees Celsius. As pressure decreases, the boiling point of water decreases with it. At the Armstrong limit, water boils at 37 degrees Celsius, which is human body temperature. This means that at pressures at or below the Armstrong limit, every water-based fluid in the human body is at or above its boiling point. The process by which these fluids transition to gas within body tissues is called ebullition. It begins in the tissues with the lowest local pressure, typically the soft tissues of the mouth and throat, and progresses inward. The gases expanding within the subcutaneous tissue cause visible swelling as the skin distends outward to accommodate the increasing volume. An unprotected human being exposed to lunar vacuum would swell to approximately twice their normal body volume within seconds, not because of external pressure acting on the body, but because of internal gas expansion acting from within. The skin does not rupture under this pressure in most cases. It stretches. The soft tissues beneath it expand into the spaces created by that stretching. The process is systemic, progressive, and in the absence of immediate repressurization, irreversible. The heart continues beating for a period after the onset of ebullition because cardiac muscle does not require the same conditions as the surrounding tissue to maintain its electrical activity. The circulatory system continues moving fluid, or what was fluid, through the vessels. The brain continues attempting to process sensory input and generate responses. Consciousness persists for approximately 15 seconds. The experience of those 15 seconds has never been fully documented. The closest analogy in the medical literature comes from altitude chamber accidents, in which test subjects were briefly exposed to near vacuum conditions before emergency repressurization. They reported afterward the sensation of moisture evaporating from the surface of their tongues, and then nothing until they woke up with repressurization underway. The moon's surface pressure is not near vacuum. It is as close to perfect vacuum as any natural environment accessible to human beings. There is no afterward without a functioning suit. The suit is everything on the moon, not a uniform, not a piece of equipment in the conventional sense, but the totality of the survivable environment for the human body inside it. The Artemis generation extravehicular mobility unit that NASA has developed for lunar surface operations is an engineering achievement of genuine complexity. A portable life support system, pressure vessel, thermal regulation apparatus, radiation attenuator, and communication platform integrated into a
wearable assembly that must maintain its integrity across a surface environment specifically hostile to every one of those functions simultaneously. The lunar surface presents mechanical challenges to suit integrity that have no equivalent in low Earth orbit operations. The primary mechanical threat is not what you might expect. It is not temperature. It is not radiation. It is dust. Specifically, it is the dust that covers every exposed surface of the Moon to a depth that varies from centimeters to meters, dust that the Apollo astronauts discovered within hours of their first surface excursions was unlike any particulate material encountered on Earth, and that subsequent analysis has confirmed